This is our example on slide 39 of our chapter 20, part 2 PowerPoint, and this is the last example we'll be working together. So the problem states gold can be plated out of a solution containing gold 3+ according to the half reaction, and I have it written on the slide here. What mass of gold in grams is plated by 25-minute flow of 5.5 amp current? So this is basically a glorified dimensional analysis stoichiometric problem, wherein we're going to take our time and use amps flowing, which amps is a unit of current that translates to 1 coulomb per second, to get us into different units. And we're also going to be using Faraday's constant, which says that 96,485 coulombs are transferred per mole of electrons. We're going to use our half reaction, number of electrons, and we're also going to be using our molar mass of gold. So the plan of attack for this, if you're looking at slide 39, is to start with minutes, translate that to seconds, and then from seconds we're going to be in coulombs, and we're going to use the 5.5 amps to do that. And then from there we can translate into moles of electrons using Faraday's constant, and then moles of electrons we can translate into moles of gold using our half reaction, and then from there moles of gold can go into grams of gold. So that's our plan of attack for this one. So first things first, in this reaction we're going to be starting with the 25 minutes. That's going to be the first number that we plug in to our basically dimensional analysis conversion. So 25 minutes, we need to get minutes into seconds because 1 amp is a coulomb per second. So let me draw my line here. We know that in 1 minute there are 60 seconds. So that cancels out minutes. And then I'm in units of seconds. And like I said in the problem, amps, 1 amp is equal to 1 coulomb per second. So I can use this 5.5 amps or 5.5 coulombs per second in my problem to get rid of the seconds unit and get into coulombs. So 1 second will go on the bottom, 5.5 coulombs on the top. Just remember, 5.5 amps is like saying 5.5 coulombs per second. So that gets me out of seconds. My seconds cancel. Now I'm going to use Faraday's constant to say that 96,485 coulombs are transferred in 1 mole of electrons. And that is a constant that we can use. It wasn't stated in the problem, but it's always going to be that exact value. So now coulombs cancel, and I'm in units of moles of electrons. And here's where I'm going to consult my half reaction. So this 3 electrons up here, that's like saying there are 3 moles of electrons transferred per 1 mole of gold. So we can translate that into an equivalency and say 3 moles of electrons are transferred for 1 mole of gold. So that's going to cancel out my moles of electrons. And the problem is asking me for grams of gold. And so here's where I'm going to use gold's molar mass. And there are 196.97 grams of gold per 1 mole. Molar mass, that's just straight from the periodic table. So 1 mole of gold contains 196 5.97 grams. And that's going to cancel moles of gold, and we'll be left in grams. So kind of a long unit conversion problem, but multiply 25 times 60 times 5.5 times 196.97 and divide that by the 96,485, and then divide by 3 moles of electrons for a final answer of 5.6 grams of gold, electroplated. So all problems like this are going to be similar. Just keep in mind amps is the same as coulombs per second, and that moaning in the background, that was my dog yawning, apologize. And you're always probably going to need to use Faraday's constant, which is 96,485, and remember that's in units of coulombs per mole. And then the moles of electrons to moles of reactant or product, that you would get from your half reaction. So, final answer, 5.6 grams of gold are electroplated in this 25-minute flow of 5.5 amps of current.